Hey guys, I'm Cyborg Sheep, and welcome to the Weekend Post. Today we solve a problem that has been holding back the channel and causing the severe lack of uploads. Today, we build a computer. Let's do this. The purpose of this computer is to live stream construction and testing of electronic projects that, let's just say, take a long time to complete. But I'm getting ahead of myself. To start off with, we've got a Gigabyte B550M motherboard, and as you can see, this project is using Ryzen AMD, baby. So necessarily, I'll be pairing it with a Ryzen 7 5700 8-core processor, and for the graphics card, I'll be using this ASUS GTX 1660 Ti. So, let's get things unboxed, start hooking everything up. But first, brake for safety. The anti-static power supply. Just a grounded metal case, just so that we don't kill anything with static. Going with some G-Skill Ripjaws DDR4. This is a 16GB kit, and thankfully I purchased this well before the price of memory skyrocketed. Check this out. This is kind of neat. Normally for the SSD, you would have like a little standoff and a screw, but instead for this Gigabyte board they actually have these little plastic retention clip thingies. Pretty handy. So, all that's left then is the graphics card. And we are ready to put in some power. from here, things are pretty simple. We have our switch here. One battery's just going to attach right here and right here for power. And the other battery is going to attach on the other side. And then finally, our power in cable is going to attach like there and right there. Finally, all the grounds are going to attach to this little terminal connector doodad that I made. Quite the wiring harness we got going here, wouldn't you say? Which brings me to why I'm even doing it this way. This computer is not going to be plugged into the wall. It's instead going to be powered using these red lithium 5 amp hour batteries. I have 2 docks, and that's so that I don't have to shut the computer down, in theory, when I'm going to switch from a almost out of charge battery to a full battery, or vice versa. That's going to take place and be possible through this switch. So one of the cells is active, and then switch it over, and then the other cell is active. And then it all goes into this power cable right here. Now, it is crucially, essentially important to remember that this is not going directly to power the computer. These batteries output a maximum of 20 volts. They're nominal 18, but for a computer, you can only do a maximum of 12, 3, and 5 volts. And with those numbers, 3, 5, and 12 volts, there is very, very, almost no tolerance to speak of. You could maybe substitute around half of a volt, 0.1 of a volt, but beyond that, no way, Jose. So that being said, this battery being 20 volts, we need some way to convert this to 12 volts. Now, how I'm doing this is a bit outside the scope of this video, and I'll get into it a little bit later. However, just remember that for now, you cannot plug this directly into the computer. It will not work. You will destroy hardware if you do. Alright then, so all that's left is 24 pin power right here. We've got graphics card power going in right here. And lastly, CPU power right here. Milwaukee battery going in onto the dock. This keyboard's a bit of an interesting story. This I actually fixed. Got a new plug end on it after somebody decided to do this to it. Stick that in. So, we have the display connected, keyboard and mouse. We have the internet. We have a bootable USB right here. All our power is wired up. So in theory, turn the power on and hopefully everything just gets detected and boots into the BIOS. Alright, I guess nothing left to do but jumper the power switch and see what happens. Oh yes, here! Oh! Huh. Alright, so on powering up the system, I get this error. This is a used motherboard, so I'm thinking this might have something to do with it. The CPU is new. Did not come with this motherboard. I bought it separately. But let's maybe just press Y. I don't think I have BitLocker. Okay, well, let's press Y and see what happens. Ooh. There we go. 3,700 megahertz. Yeah. Alright. Cool. So. Okay. We'll just enter the BIOS, I suppose. XMP disabled. We'll want to enable that. Alright, looking around the BIOS for a little bit, everything to my untrained eye looks to be okay. I figured out how to get XMP working so the memory is running at its proper speed. So we are just going to save and exit and see what happens. Yes. Okay, we're loading. Ooh. Oh, there we go. Perfect. And just like that, we have a Windows desktop. And better yet, check this out. No bloatware. Ignore this. Cool, right? I'll leave a link in the description. Alright, I didn't particularly want to try this now. Unfortunately, this battery is only at 2 bars. We are going to throw the switch. Ah, frick. No. Okay. Ah, that sucks. I was really hoping that this switch would flip fast enough, or change the power over quickly enough, that the system wouldn't reboot, but unfortunately that doesn't look like it's the case. Well, for all intents and purposes, there you have it. The live streaming computer is finally working! Yes! That is so awesome. However, there are still several issues to work out. The computer still needs a case, the low charge issue, and the issue of not being able to switch over without rebooting. We need to get the internet connectivity switched over to run wirelessly with that right there, or possibly also a different, or I'll use one of these maybe 8X or 1X slots for a network wireless card. And yeah, need a mouse, keyboard, and all that stuff, but for now I think that's pretty good. So hit that like button if you liked it, subscribe if you're new, and I'll see you dudes in the next episode.